Hi everyone, welcome back to my next session. Now I'll be sharing my screen. So as of now, uh, in the biometrics, we discuss about what is an image, what is a digital image processing, and we discuss about what is a 2D image as well as what is the 3D image and what will be the function we'll be using for 2D as what will be the function we'll be using for 3D. And then we discussed about the formula for image negatives. And then we discussed about what is the formula for the degraded process. And then we discussed about the difference between image enhancement as well as the image segmentation process, and then how the image segmentation process going to happen. That will be happening through the machine learning algorithms. And then we discussed about the flow chart of the image segmentation in the last lecture. In this video, we are just going to discuss about the fingerprint. So everyone know what is a fingerprint. I already discussed more about the fingerprint. So the new topic we are going to discuss in the fingerprint will be the ridges and the valley. So you know what is the feature extraction. I'm going to take a input, and through the input, the feature extraction will be made. In the feature extraction, we'll be applying the Minuti algorithm for the fingerprint. So Minuti will be represented as a ridges. And then in between the multiple minuties, there will be a gap. That will be gap will be represented as a valleys. So ridge width is given here and ridge valley width is given here. Okay, always if while I'm giving the input to the glass surface, which I'm using for the biometric system of for the fingerprint, only the ridges will be falling on the glass surface. The valley won't fall on the glass surface. So it is clearly understood that depending upon the ridge values, I mean, depending upon the ridges only, our input will be captured. Now, so these are the sensors that we are going to use. So now we have to discuss about what is offline as well as what is online. So through this diagram, I'll be discussing about it. What is offline as well as what is online. So A, B, C. A represent the rolled fingerprint, B represent the plain fingerprint, and C represent the latent fingerprint. So B represent the plain fingerprint that we are using in an organization. So that's what. If you're using in an organization, automatically you will be using a sensor. Through your sensor, through the input, the biometric system will be capturing your identity. So automatically that is understood that it is known as the online fingerprint. So it is understood that the online fingerprint will be the plain fingerprint. And what is the remaining two things are the A and C. A is a rolled fingerprint and C is the latent fingerprint. This both the things that will be coming under the offline. So what does the A rolled fingerprint represent? That is that some will be an uneducated people, right? So they don't know how to put the signature. Automatically what they will be doing is that through the inks, what they will be doing is that they will be keeping their fingerprint. I mean, they'll be keeping their hand on the paper. So that's what it was represented here. So the digital image directly it will be taken from the fingerprint. Rather, the fingerprint is firstly transferred to the substrate. Example, the paper that is subsequently digitalized. That's what the inked fingerprint. That's what we'll be keeping the fingerprint in the ink and we'll be applying straight away in the paper. That is known as the rolled fingerprint that comes under the offline technology. And third one will be the latent fingerprint. So latent fingerprint, you can look into that. Latent fingerprint can be lifted from the objects in a crime scene using the chemical or the electrical process. The thing is that if there is any crime scene happen, what we'll be doing is that they will be finding out the criminals by using the latent fingerprint. How they will be identifying it? Through the fingerprint as well as through the footprint. But I already said the footprint, through the footprint, we cannot identify the criminals or identify the individual. The reason is that the footprint will be very dirty. So only it will be very difficult to identify the criminals by using a footprint. Only option will be the fingerprint, but that also only the 30% of the possibility. But why I am explaining this latent fingerprint is that you have to understand what is the offline and what is online. Online is the plain fingerprint, and offline will be the, what are the things? This one, rolled fingerprint and the latent fingerprint. So these are the types of the fingerprint. If you take a types of the fingerprint, there are two things are there, offline and the online. In offline, rolled and latent fingerprint will be coming, and in online, the plain fingerprint will be coming. Now, there are three steps are available in the matching. First is an alignment, second is the correspondence, and third is the score generation. So, now I already said we are discussing about the fingerprint. So, if it is a fingerprint, if a feature extraction will be made, always will be using the minuity matching algorithm. If you are taking the minuity algorithm, automatically through the ridges, only your input will be captured, not through the valleys. Now, always I said, will be taking out the multiple inputs from the user. So multiple inputs are taken. You can look into this image. So, but the problem here is that while I'm taking a multiple samples are taken at a different period of the time. So there will be a problem with the alignments. So what you have to do is that after taking a multiple samples, we have to align it. After making an alignment, we have to pair it. And after making a pairing, finally you have to identify the score. So while we are writing in the algorithm itself, we have to make sure that, so if the score is more than this particular, I mean, if the score is more than 75, we have to make sure that it is matching. If it is less than 75, it is not matching. While writing this minuity matching algorithm itself, we have to highlight this as a most important point. Now, this is what it was represented as. So, since the two impressions of the same finger taken at the different instance, so it could differ due to the different placement of the finger. So, we have to do the alignment process. That's what I said. After making an alignment, I have to do the pairing, and finally, I have to identify the score. So, you can look into the first image. The match score equal to 614. So, the match score is high. It is already automatically understood that, so both the samples are matching because the match score is very high. So it is coming from the genuine pair. So you can look into the image of B. So match score is very less compared to the match score that we discussed previously. So automatically it is understood that it comes from the different samples. I mean, it came from the different individuals. So in this video, we discussed about what is the fingerprint. In the fingerprint, we discussed about two types of the fingerprint. First is the offline fingerprint and online fingerprint. And then we discussed about what is the ridges and the valleys. And then finally, we discussed about the three steps of the matching. One is the alignment, and second is the correspondence, and third is the score generation. So now I'll be stop sharing it. And in the next lecture, we'll be discussing about what is a PCA and what is an LDA problem. Why we are mainly discussing about that is that because the range of the data sets will be very high. To reduce the data set, we'll be using the PCA and LDA. That will be discussed as a problem in the next lecture. Thank you. Now I'll be stop sharing.